Antiderivative is something that undo a derivative. Example, we know that the derivative of sin x is cos x. This implies the antiderivative of cos x is sin x. But since the derivative does not determine the function completely, you have to add a constant. Therefore, antiderivative of cos x is sin x plus c, and it is written as integral cos x dx equals sin x plus c. This symbol is called an integral. Now, just like derivative have some properties, integration also has some properties. So, integral of f of x plus g of x with respect to x is written as integral f of x dx plus integral g of x dx. That is, you can distribute the integral across addition. The second property of integral is that if k is a constant, then integral k into f of x dx equals k into integral f of x dx. That is, a constant can be taken out of the integral sign. And the third property is that if we have integral dx, then this is equal to x plus a constant. Remember that we don't have a simple product rule here. That is, if we have a functional form like integral f of x into g of x dx is not equal to g of x into integral f of x dx plus f of x into integral g of x dx. For polynomials, we know that the derivative of x raised to k is k into x raised to k minus 1. This implies the antiderivative of k into x raised to k minus 1 is x raised to k. Therefore, integral of x raised to k dx equals x raised to k plus 1 by k plus 1 plus constant, where k is not equal to minus 1. To give an integral of a polynomial, consider the integral of 3x cube minus 4x square minus x plus 7 into dx. By using the properties of integration and the formula for x to the power k, we get the final answer as 3 into x to the power 4 by 4 minus 4x raised to 3 by 3 minus x square by 2 plus 7x plus a constant. If the given integral is like integral of cos of 2x dx, then we can use the change of variable method to evaluate this integral. In this method, we replace the function of x with a variable y. In this case, let 2x equals y. If we differentiate on both sides, we get dx equals dy by 2. If we substitute this thing in the original integral, we get integral cos of y into dy by 2. This evaluates to half into sine y plus a constant. If we resubstitute the value of y, we get the final answer as half into sine 2x plus c. Suppose we want to find the area under the curve of irregular figures. Like, given a function f of x, what is the area between f of x and the x-axis from a to b? To find the area, we divide the interval a to b in very small pieces, each of width dx. Since dx is very small, then in that small interval, f of x can be taken as an almost straight line. Then the area of this small rectangle is f of x into dx, and the total area under the curve f of x from a to b is given by the sum of these small rectangles. This is mathematically given by the definite integral of f of x from a to b. The definite integral is basically integration in an interval. In this case, it's from x equals to a to x equals to b. To give an example, consider the integral x dx evaluated from x equals to a to x equals to b. This evaluates to b square minus a square by 2. Another example is that integral of cos x dx from a to b evaluates to sine of b minus sine of a. Therefore, the answer of a definite integral is always a number. Definite integral have some properties. The first property is that if we interchange the initial and the final limits of the integral, then we get an extra negative sign outside the integral. The second property is that if a is less than b and b is less than c, then the integral over the interval a to c can be divided as integral from a to b plus integral from b to c. And the third property of definite integral comes from the fundamental theorem of calculus, which says that if we evaluate the integral of df by dx from a to b, then this equals to f evaluated at b minus f evaluated at a. We know that the time derivative of velocity is acceleration. This implies the antiderivative of acceleration will be velocity. Similarly, time derivative of position is velocity. This implies the position as a function of time is given by the integral of velocity over time. Therefore, if we know the velocity of a particle as a function of time, then the total displacement of a particle from time ta to time tb is given by integral from ta to tb of v of t into dt.